Okay, in this video I will cover on the pressure measurement. We continued from the subchapter 2.1.2. Okay, now let's have a look on the pressure measurement. So the objective for this pressure measurement is explain the pressure measurements, describe the importance of pressure measurement, explain the basic operation, list advantage and disadvantage of each pressure measurement device, explain the criteria for selecting a suitable pressure measuring device. So the objective is just the same as a flow measurement, right? So now under this topic we will cover the introduction to pressure measurement, a few type of pressure measuring device, which is manometer, deflection type sensor. Under deflection type sensor we have Bourdon tube, bellows type, diaphragm, strain gauge sensor. Okay, so now I move to introduction. Okay, what is pressure? Okay, so when we talk about pressure, we will know pressure is equal to force exerted by a fluid per unit area. So F over A. So when we dealing with pressure, so the mixture that we will deal is a gas or liquid. So the following terms are the terms related to pressure. So atmospheric pressure is the pressure exerted on a surface by the weight of air. So basically atmospheric pressure is a pressure surrounding us. So in the ideal situation we have a atmospheric pressure surrounding us, around 101,325 kPa. Okay, absolute pressure. So basically absolute pressure is a pressure absolute for that matter. For example, we have argon gas. The pressure of the argon gas without consider the atmospheric pressure. So basically the condition for the absolute pressure is a perfect vacuum. So gauge pressure is a pressure where we consider atmospheric pressure together with the absolute pressure. So if we have a metal argon gas at a certain pressure and we have to add up with atmospheric pressure, then we get a gauge pressure. So next, vacuum pressure is a pressure below the atmospheric pressure. Okay, next pressure is static pressure. Static pressure is a pressure that exerted by a fluid that is not moving or flowing. So that fluid is in a static mode. For dynamic pressure is a fluid, the pressure exerted by a fluid that is in motion. Straightforward, right? This one. So stagnation pressure is where pressure at a stagnation point. So when recall back your fluid mechanic, right? If you have a movement of fluid along the plane or aeroplane or plate, so there's a velocity of air from here to here, right? But when it approaching to the surface of the wall of the plane or any surface, the velocity at this point is equal to 0, right? So actually at this point we call it as a stagnation point. So stagnation pressure is the pressure at the stagnation point. Okay, why measurement of pressure is important? It is used in almost all industries. Some of its important applications are listed. For example, to ensuring safe operating condition of boiler, helps in determining the liquid level in tanks and container, help determining of the density of the liquid, serve as an indication of flow rate in many flow meters such as venturi meter, orifice meter, flow nozzle, the one that you learned in the previous videos, right? So basically pressure is a main important parameter that we will use inside the process. Okay, now we move to first type of pressure measuring device, which is manometer. So manometer is used to measure small and moderate pressure difference. So the manometer consists of a glass or plastic U-tube, like this figure. It contains one or more fluids such as mercury, water, alcohol or oil inside this U-tube. So the basic operation for this manometer, I think this one you are already familiar because you have learned inside the fluid mechanics. So okay, inside here, if the unknown pressure is fit inside the U-tubes, it can cause the fluid, the manometric fluid, to move to the certain value, to the certain height. So we will read the height of this manometric fluid in order to calculate the pressure. So basically, the pressure at point 1 and point 2 here can be neglected because the value is the same. So here we can cancel it out. So to calculate the pressure for this manometric, so we just need to use this kind of formulas. So pressure at point 2 here, because we have an atmospheric pressure also fit inside the U-tube. So we need to consider the atmospheric pressure plus with the density, gravitational acceleration and also height. This one is a P formula. So we will get the value of P2. So basically this is how the manometer working. So the cross-sectional area of the tube has no effect on the differential H. However, the diameter of the tubes, this diameter, should be large enough to ensure the surface tension effect, and the capillary rise is negligible. Why we need to have a sufficient diameter? Because sometimes if the pressure is too because certain diameter can withstand certain pressure, so we need to confirm, find the suitable diameter to handle suitable pressure. Okay, next type is deflection type sensor. So this sensor use an elastic material to convert pressure to displacement. So basically stainless steel or brass. So next, the displacement will be proportionate to the value pressure exerted. It means if there is a changes of displacement, it shows that the pressure also change. Suitable to be used in an automatic control system. The main element used in the shape of Bourdon tube, bellow or diaphragm. So the secondary element is the element that will convert the displacement to electrical signal, where the displacement can be detected through resistivity change, inductance or capacitance. So basically, the displacement of the Bourdon tube or bellow or diaphragm will be converted into the electrical signal first. So this displacement basically can be detected based on the resistivity change, inductance or capacitance. Okay, now I will explain about the first type of this deflection type sensor, which is Bourdon tube. So Bourdon tube consists of a hollow metal tube bent like a hook. This one, the grey color one. So this hook, whose end is closed, so its end is closed and connected to a dial indicator needle. So it is connected to this indicator needle, whereas the other end is connected to the source of pressure. So here, source of pressure that is being measured and mounted in such a way that it cannot move. So the basic operation is, when the tube, this tube is open to the atmosphere, the tube is undeflected and the needle on the dial at this state is calibrated to the 0. Okay, so after the fluid inside the tube is pressurized, the tube will tend to straighten out, which will cause a small amount of movement of this tube. So when there is a pressure exerted here, so basically at first this type of meter, it's set to 0 under atmospheric pressure, and then after we exerted a pressure inside this tube, the Bourdon tube start to deflect. When it's deflect, it causes the needle to move from here to here. So from here we can read the pressure difference, right? So basically, for your information, these Bourdon tubes, the pressure measured is in gauge pressure. Okay, now we move to bellows type. So bellows is an elastic element are made of brass, phosphor, bronze, stainless steel, beryllium copper or other metals suitable for the intended service of the gauge. So basically, for your information, all this type of metals is a soft metal. It can bend or can be deflect after we exert a certain amount of pressure. So the basic operation for this bellows type is, so basically there is a pressure exerted in here, so this spring will move according to the pressure exerted. So when the spring is moved up, when the pressure exerted here, the spring will move up and cause this sector to move, and this sector will move and cause the scale to move according to the pressure exerted in here. So basically, the relationship between the applied pressure and the bellows movement is linear. You can see, right, it is linear. When we exert the pressure, and then the spring will move, and the sector will move and cause the scale to move also. So it is a direct proportional relationship, right? Okay. Now we move to diaphragm. So diaphragm use the elastic deformation of diaphragm, such as membrane, instead of liquid level to measure the difference between unknown pressure and a reference pressure. So the diaphragm contains a capsule divided by a diaphragm. So basically, inside here we have a external pressure that we exert, and we have a reference pressure. So the difference between these two, we will get the pressure difference. Okay. So for example, it can be detected. So the membrane deflection can be measured in any number of ways. For example, it can be detected via mechanical couple indicating needle and attached strain gauge, or with many other displacement or velocity sensor. Basically, this diaphragm can be attached to listed to the listed measurement or sensor. So in here we can see that there is a diaphragm down here. Okay, so when the pressure exerted here, there's a pressure reference here. So based on this, the needle will move according to what the amount of the pressure exerted at the bottom. Okay, for this, all this pressure measurement device, I will give you a YouTube video for you to see clearly the working principle of each of the measuring device. So the advantages and disadvantages, I think you can read from here. It is straightforward. Let me pick only one point. So for the Borden, the Borden cost is low, Bellows is moderate, diaphragm also moderate. So the disadvantage is low spring gradient for the Borden. For the Bellows, we need to have an ambient temperature compensation needed. So for diaphragm, the disadvantages is the lacking good vibration and shock resistance, because it is membrane, right? So it's quite sensitive. So last type of pressure measuring device is strain gauge sensor. So this strain gauge sensor is a resistive transduction type. Okay, it will measure the pressure difference between two locations directly through displacement of elastic element. So available, so this type of sensor available for pressure range as low as 3 inch of water to as 200,000 psig. It's around 1,400 MPa. So this device also can detect gauge pressure if the low pressure port is left open to the atmosphere. So this one, if it is open to atmosphere, we can detect the gauge pressure. So if the low pressure site is a sealed vacuum reference, the transducer will act as a absolute pressure transducer. So if this one is connected with the sealed vacuum, and then we can have a absolute pressure for the metal itself. So the basic operation is pressure is measured through force that is exerted on the elastic diaphragm. So this is diaphragm. We can see the elasticity of the diaphragm. It can bend, where the force will be detected by the strain gauge, and resistance change will be produced. So when the diaphragm moves, there is a the force. When the diaphragm moves, the force will be detected by the strain gauge here. So when the strain gauge detect the movement of diaphragm, it can say that there is a resistance change of the flow, resistance change of that metal. So from the resistivity change, it can be used to detect the change in pressure. So the change of resistance just now is sent to the amplifier here, the amplifier is used to amplify the small output signal. So later on you try to see the YouTube video that I give so that you can understand more on how they working. But for this strain gauge sensor, basically there's a pressure difference between these two. So this pressure difference causes the diaphragm to move. When the diaphragm when the diaphragm move, the strain gauge will detect, and the resistance change will be produced. So those resistance change signals will be sent to the amplifier, and from that we can see there is a we can measure the pressure difference. So the advantages and disadvantages of these two type of measuring device, which is manometer and strain gauge. So basically we know, right, manometer is simple, availability of a wide range of filling fluids, varying specific gravity, reasonable cost, suitable for low pressure. Strain gauge is low cost, good dynamic behavior, good linearity. So this one basically from what we see, we can directly see the advantage. When you look through the video of the working principle of manometer and strain gauge, you can see the advantage of each of the device. Okay, so that's all for the pressure measurement. I will continue with the chapter 2.1.4 till 2.1.6 on the next week video. Thank you.